So let's go to steps in pyruvate decarboxylation. So pyruvate dehydrogenase has a prosthetic group called TPP, that is thiamine pyrophosphate, that is used to attach to pyruvate and remove carbon dioxide. So we have thiamine pyrophosphate. It looks like this. This is done in presence of acidic condition. So when our TPP, thiamine pyrophosphate, reacts with pyruvate, it forms hydroxyethyl TPP. And carbon dioxide is kicked out. So this is the carbon dioxide part that is normally kicked out. So we go to step number 2, where we have the hydroxyethyl group being transferred onto lipoamide group of protein complex, forming acetyl lipoamide. So this one is added to lipoamide. So this is the lipoamide group. So the important part of lipoamide group is this disulfide bond. The one having 2 sulfur atoms. So when hydroxyethyl TPP reacts with the lipoamide, this group or this particular part gets attached to one of the sulfur atoms, and the other sulfur atom is normally attached to a hydrogen atom like as follows. So we shall have our TPP being regenerated. Plus this group attached to our lipoamide. The group is attached to our lipoamide. So this one is called acetyl lipoamide. let's see, one of these hydrogen atom will be attached to the sulfur atom here, and another one will be attached here on this lipoamide. So for us, this is our R3, and our hydrogen atom here. And the resulting compound is acetyl lipoamide. The next step is formation of acetyl-CoA. So this is our step number 1, step number 2. We go to step number 3, formation of acetyl-CoA. So dihydrolipoyl transacetylase then transfers the activated acetyl group from lipoamide onto coenzyme A. So dihydrolipoyl transacetylase role is to transfer this acetyl group onto coenzyme A to form acetyl-CoA. So the importance of putting this particular group onto lipoamide is to activate it to become acetyl lipoamide. So the next step will be the transfer of the activated acetyl group from acetyl lipoamide onto coenzyme A to form acetyl-CoA. So that is step number 3. So this is our molecule. This carbon. So it reacts with our coenzyme A. And this forms acetyl-CoA. This is our acetyl-CoA plus our dihydrolipoamide. So that is basically what happens, this being our R3. So we go to step number 4. We want to regenerate our lipoamide. Regeneration of lipoamide. So our dihydroxylipoamide reacts, this dihydroxylipoamide, it reacts with the FAD positive. Dihydroxylipoamide reacts with the FAD positive to form lipoamide. This is our R3 SH. So it forms with FAD positive. To form our FADH2 plus our lipoamide. I want to redraw, sorry for that. This is S, this is S. So dihydroxylipoamide reacts with the FAD plus to form FADH2 plus our lipoamide. So our next step is the reaction of this FAD, reduced form of FAD, with NAD plus to form NADH. This forms NADH. Plus our FAD plus our hydrogen ions. So these molecules are very important as they are used in the electron transport chain. Thank you.